We look at the starting point, the first vertex, and we label that with a 0 and we circle it. It's the shortest way to get to A, 0. We look at all the neighbours from A. So we can go to B, which will cost us 2, or C, which will cost us 6. We now choose the lowest of all the uncircled values, 2. And we got there by coming from A. Now let's label all the neighbours of B. So E, 2 plus 6 is 8. D, 2 plus 4 is 6. And C, 2 plus 2 is in fact 4, which is better, a shorter path than 6. So now we look at all the uncircled values on our whole graph. 8, 6 and 4. 4 is the lowest, so we're going to go there, and we're coming from B. Now let's look at the neighbours of C. We've got D, which has a 6, but we can get there a better way. 4 plus 1, coming from C, is 5. Now let's look at all the uncircled values on our graph. 8 and 5. 5 is the lowest, so we'll circle that. Now from D, let's look at the neighbours we can go to. We can go to E and F. E, we could take 5 plus 7. 5 plus 2 is 7, which is better than 8. And F, 5 plus 4 is 9. The lowest uncircled values here is 7. So we'll go there from D. And I forgot to put an arrow. We went from C to D. Now we're at E, and the only uncircled neighbour is F. 7 plus 1, that's better than 9. And that's going to be the value of the shortest path. And working backwards, often there's multiple paths that you've taken. So from F, we came from E, came from D, came from C, came from B, A. So that's the path that we took. And we can label that A, B, C, D, E, F. Nice order there. We're using Dijkstra's algorithm to find the shortest path again, but I've changed a few of the numbers here. It may be a different path and a different value, but we'll use the same method. So we start at A with a value of 0. We look at the neighbours and label their values. 2 is the lowest, so that's the path we'll take. We'll use an arrow to show that. And now we'll look at the neighbours of B. So to get to C, we can actually get there with 4, that's better. To get to D, 2 plus 3 is 5. And to get to E, 2 plus 2 is 4. Now we have 2 neighbours of B that have the same value. C is 4 and E is 4. So we could choose either of them. Just choose one and see what happens. It'll all get worked out in the process. So I'm going to actually go down to C, and then from C there's only one neighbour, D, which is 5. And then from D I look at the neighbours E and F. Let's label them. Let's do F first. 5 plus 5 is 10 to get to F. And to get to D, 5 plus 2 is 7. But notice how 7 is higher than 4, and we want the shortest path. So we're not going to use that 7, we're going to keep that 4, which is, we got that 4 by coming from B. So we circle it because we know 4 is the shortest way to get there. And now that we're sitting at E, we look at our neighbours, F, and 4 plus 3 is in fact 7, which is better than 10. So we'll cross out the 10, we've got 7, and we came from E. So the value of the shortest path is 7. And how did we get there? Let's work backwards. We finished at F. We came from E to get to F. When we're at E, we came from B, and then we came from A. So this is our shortest path. We're doing a more complex question for Dijkstra's algorithm. So we start at A, circle it as 0. We look at the neighbours of A, 1, 8 and 5 to get to those. 1 is the lowest, so we'll circle that, and we're coming from A. The neighbours of B are just G, so 7 plus 1, that's 8. So what do we circle now? We have to consider all the uncircled values. So 5 is the lowest, so we're actually going to abandon our path through B, and let's look at this new path through D, because that's the lowest. From D, we can go to F with 9 and J with 7. Again, we look at all the uncircled numbers. 7 is the lowest, so we'll choose that. From J, look at all the neighbours it can reach. F, we're not going to replace that 9. 9 is still the lowest for F. What about going to I? 7 plus 3 is 10. And going to H, 7 plus 3 is 10. Now we can't assume that 10 is the lowest or the shortest way to get to H, so we're going to continue until we finish this properly. So let's look at all the uncircled values, and we really have to choose the lowest one. So maybe we'll choose that top one, G. 8 is the lowest, so let's circle that. How did we get there? We came from B, 1 plus 7. Now let's look at the neighbours of G. To get to E, 8 plus 16 is 14. And to get to H, 8 plus 5 is more than 10. So we're not going to replace that 10. Again, looking at the lowest of the uncircled vertices, we have 8. So I'm going to circle that and create this new path from A to C. Let's look at the neighbours of C. 8 plus 5, that's actually 13. We'll replace that with a lower value. And to get to F, 8 plus 10, that's not better than 9. All right, again, so we've looked at all the neighbours of C. We have to look at the lowest uncircled value, and that's 9. So we're going to circle that. That is definitely the shortest way to get to F. And that came from D. 5 plus 4. Okay, F, the neighbours of F. Going up to E, 9 plus 4 is 13. So that's just the same as what's already there. 9 plus 7 to get to I, that's greater than 10, so we won't replace that 10. Now, looking at all the uncircled vertices, they're the only ones left. There's no more vertices without values, so we're going to choose the lowest value, and we might as well choose this one as the lowest instead of I, because that's where we want to get to. How did we get that 10? We came from 7. 7 plus 3. Oops, I forgot that one there. Okay, so there's kind of arrows and circles all over the place. So we have to trace our way backwards. So from H, we came from J. From J, we came from D, and from D, we came from A. So our path is A, D, J, H, and our value is 10.